Okay, in this final video, I would like to go through the post-processing process and the measurement process with Astrometrica, and finally submitting the data to the Minor Planet Center. So for my post-processing, the bias subtraction, flat fielding, dark correction, I use a program called AstroImage-J. It's a free program. I like it because it's free and because it does a good job. And it does a lot of other science stuff. It's really geared for analyzing light curves. The person that wrote this primarily wrote it, I believe, for exoplanet transits. But it certainly can be used a lot for general astronomical processing and some science processing. But if you have an interest in exoplanet research, I strongly suggest looking at this program, AstroImage-J. It's free. So to start off with, I've got it loaded down here, and it's actually a Java program. And to process the images, you select this DP button, CCD data processor. It brings up this window here. It can be a little overwhelming when you first look at this. I know I certainly was. Basically, what you do is you have a place where you tell it where your various files are, the science images, your bias, your dark, and your flat. You have the ability to create those if you're building a library of dark images or creating some flat fields. We're not going to do any of that. I've already got that all set up. And basically you come up here to the top and you select where your images are. In this case, we're going to be processing this asteroid 138155. And this is the one that I took 5 images at 10 seconds each. So when I select this, these are going to be the raw images. Haven't been post-processed at all. So I just select one of these. Any one of these is fine. And it fills this field in here. And unfortunately, I think it's not happy with these parentheses. If the parentheses weren't there, then this would show the total number of science images in this directory. So what I have to do for these file names that have parentheses in there, I basically just delete all that and delete that, and we're just going to process star.fits. And now it shows, okay, we've got 10 images in there. Here's my location of my bias frame. Here's the location of the dark subtraction, and it's a 10-second dark for it match the 10-second raw image. And here's my flat field, and all of these are enabled, so we're going to process all of these. We want the scale and debias also selected. And in this case, I'm going to remove outliers because there's a couple of hot pixels right near the center of my field of view that kind of interfere with the asteroid position. Normally, I don't have this on, but for this specific example, I'm going to turn it on just to remove those hot pixels to make the asteroid easier to see. Sometimes this can help for faint objects as well, but this is not a faint object. So really, I normally have this off, but for this one example, I have it on. And it's going to save the calibrated images. It's going to put them in a subdirectory called pipeline out, and I'm going to save them as 32-bit floating point images. So I'm going to click on Start here, and this is just going to go through real quick. It's only 10 images. Now we're done. So that's it to the processing. One thing I like about this program is you can tell it to watch a certain folder here, and you can turn on this polling interval. Say set it for 10 seconds. And that means that every 10 seconds, this program is going to check this folder for any new images in it, and it will automatically process them. So you can actually use this program live while you're taking images, as your camera is dumping the raw images into this folder that you specify. This program will see it and automatically process it. I just find it a nice feature so that at the end of the night, I don't have to go through and process dozens and dozens of pictures. They're already done for me. If you set this to 0, then you have to do it manually. Okay, so that's really all you do in Astro Image J. Coming here to Astrometrica, I've already gone to the internet and downloaded the current orbital elements. That's always a good way to start. And now we're going to load in the processed images. So we want to stack these together. Remember, we have 5 images at 10 seconds each. Click on Stack Images, Add, and I just happen to have this in the default directory in Pipeline Out. Here's the raw images. Pipeline Out is where it's saved the calibrated images. And I'm just going to grab these first 5. 1, 2, 3, 4, 5. Open them up. Now I can go through each one of these, pick a star field somewhere in here, and go through and look and see the quality of each image. Because there were only 10-second images and they were unguided, these all are pretty good. They're fine. Occasionally a gust of wind will come up or something and these star images will be elongated. If you get a bad one in the series, you just click on Remove. But all these are good, so we'll click OK. And it's asking for the time and date of the mid-exposure. These are all fine. It's getting these from the FITS header. You don't have to do anything here. Now you need to tell it, well, okay, how do you want to stack these images? So click on this, and I believe the object was what was the name of the object we were looking at? 138155. So 138155. Search, and I go search through the entire database, and it found one match. Sometimes there'll be several. But in this case, 138155. So we will select that. That automatically populates the rate of motion and the position angle of motion. That is a huge help to processing these images. We're going to add them together and just click OK. It adds them all up. It finds reference stars. All these green circles are reference stars. It's a little bit of a summary down here. It found 48 stars. It's using 22 for reference, 22 for astrometric reference, and here's the average error in the position of 0.46 and 0.41 arc seconds. Not great, but good enough. And some other information here we're not going to worry about. So that's the first set of images. Let's go back and do the second set. Second set of 5, or these last 5. 1, 2, 3, 4, 5. And you can see the date and time. If I wasn't quite sure as to where the first set ended and the second set started, a lot of times I go down these dates and times and I see, okay, here's UT1, 24, 24, 25, 25, and then here's 209. So here's the first set, here's the division, here's the second set. If there was a third set, there would be a clear division in the time. So sometimes it's helpful to go down these lists here these file names. Open them up. Again, we can go through all these to check for any bad ones. Just know that they're all good. So it remembers this motion from the last time, so we don't need to do anything here. And so now we have the two stacked images. Somewhere in there hopefully is the asteroid. Well, now what you do is blink them. Yes, you can click here and it will show all of the known asteroids on the display. That's good for a check, but I find it more fun to see if I can find the moving dot. So without knowing where it is here, I click on the blink and I move this up, and let's look at the whole thing. Okay, where's the moving dot? Hopefully it's somewhere near the center. That would be good. And I do see it. Hopefully you can see it. It's right here, there, and there. Don't see anything else moving. So we can stop the blinking and we can overlay all the known objects. And sure enough, here is our target, 17.9. You can see there's some other things in here. 21st magnitude, 21st, 21st, 24th magnitude. I can guarantee that I am not going to capture those. If we look at the next image, sure enough, our next image shows the asteroid here, right in the center of this little box. That's good when it's in the center of the box. Sometimes it's not. Sometimes it is way outside the box. That means that the orbit is probably in need of some serious refinement. What I have found a lot of times is that if it's not in the box, generally it's going to be somewhere along the line of motion, meaning this object is moving this way, okay? It's moving something like that as you blink the images back and forth. So if it's not in the box, it's probably going to be somewhere along the line up here or down here. Oops. Along this line of motion. That usually means that the mean anomaly was a little off. That seems to be the most common occurrence. So when you don't find it in the box and you know it's bright enough that you should have it, start looking along this line here if it's not immediately obvious when you blink. Okay. If this object had been one of those new objects from the NEO confirmation page, you need to have loaded in those specific orbital elements as I described in the previous video. If you do that, then Astrometrics will draw a little box around where it thinks that new object should be. If you haven't loaded in those elements, as I described before, then you don't get a little box to show you where that new object might be. I have found it very helpful in locating new objects to have that little box on the screen. And this field of view here that I've got is pretty small. It's about 15 arc minutes by about 12 arc minutes. So I don't have a huge field of view here. It certainly works, and I certainly can catch a lot of objects, but sometimes the new objects can be substantially off from where they are predicted to be. Depends on how many observations they've had over how many days and how long it's been since they've last been seen. But anyway, having the ability for Astrometrics to draw those little boxes around the new objects is a huge help, I have found. So we want to make these two measurements of this object. So we put the little crosshair over the dot, click on it, and Astrometrics automatically calculates a centroid, and that's what you're seeing here is a graph of how well the light intensity follows the centroid. If you need to move it around, you can click here and do that, but this looks pretty well centered. It looks nice and symmetric. So now we need to identify this object. So we click on this. And this is another super great thing that Astrometrics does. It has gone through all those asteroids and looked for ones that are close to this position. And it has kind of put them up here. This is a huge help. So here it sees 138155. The error in the position that from where you've measured it to its predicted position is pretty much dead on here. Its magnitude, its speed, and position angle. So yeah, we can be pretty sure that this object we've identified is in fact this asteroid. So we'll click on OK. Populates this here with a compressed version of its name. You can learn more about that from the Minor Planet Center. We'll click on Accept. So that's the first measurement. Go to the next dot. Click on that. Not quite as sharp an image as the first one, but it looks still pretty good. It's definitely usable. Click here. Searching objects, 138155 is certainly the best match. Sometimes you have to go down here a little bit. If this were one of those new objects, then it will also show up in this list as a choice. I find that a huge help. It gives you an idea of the offset. Say this was a new object and the position you're measuring is say 3.4 arc minutes off in RA and 10 arc minutes off in DEC. Well, if you go to your first measurement and you get the same offset for your first measurement as your second measurement, then chances are pretty good that yes, that object you've identified is in fact that new asteroid. So again, having the ability to see the new ones in here is a huge help in confirming that's what you actually correctly got the image. So we'll click on OK and Accept. And now we're done. We're ready to send this measurement off. If you go up to here and view the UMPC Report file, it's going to show you the correctly formatted file of the two measurements that we just made, the correct header information, and then the two observations here in the proper format, the name, the date, the time, the right ascension, the declination, magnitude, and observatory code. So to send that off, you can copy and paste this into an email, but an easier way is to go to Internet, send UMPC Report. Here it's formatted who it's going to. It's going to send me a CC, the subject. It's all set out, formatted properly. This needs to be plain text, not HTML. Their automated routine needs to have this as plain text email. So if I were to click on send, this would go off, and a few minutes later I would hopefully get a confirmation that they'd received it. Since I've already submitted this, I'm just going to hit cancel. So that's the basics of post-processing, how I do it, using Astrometrics and using AstroImageJ, two very excellent programs. I'm going to add one last example here at the end of an object that was pretty difficult. And I'm going to show you how I use the program called Find Orb to check my results before sending them off. How to download the current positions from the Minor Planet Center and add them to a text file, and then add my observations at the end, and finally run them through Find Orb to see how I did. So the object I've chosen is one of these newly discovered objects. I've already post-processed the images, flat-fielded and biased and dark corrected them. So I'm going to load those in, and I'm already in the directory here, and this object was pretty faint, so I did 10 subs of 30 seconds each. I was also fighting a little bit of haze while I was taking these. So I'm going to grab these last two sets here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? Yes, because you can see the time here for this last set starts at 4 hours 50 minutes UT, and the one before that was taken at 4 hours 44 minutes UT, so there's about 6 minutes difference here. So yeah, that's the break. I'm going to open those up. I'm not going to go through checking them. Load all 10 of those in. And I'm going to do a search, and again I've loaded the preliminary orbital elements from the NEO confirmation page into Astrometrica, as I described earlier. So I can click on the search button, and I'm going to search for the asteroid P10AFQA. It's a funny little name that was given to it by the observatory that discovered it. That's where the initial designations come from. And sure it is, there is that object. That appears here because I've loaded those orbital elements into the database for Astrometrica. Click on OK, and it automatically fills the speed and the position angle. We're just going to add those together. Okay. Make that full screen. Somewhere on there is this object. We'll add in the second set. Let's see, we said the division was here, so this is the last one of the next set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I see that the previous one here was at 433, and this one is at 439. So yeah, we've got all of the ones from this set in here. And load those in. I'm not going to check them. Already done that. Remembers the parameters here. Just kind of as a check, you can see the error in right ascension and declination here are pretty good. 0.3 arc seconds. So if we blink these two, hopefully we'll see one that's moving. This one isn't very bright. This one is not an easy one. If you look right here in the center, you can see a faint object moving, hopefully. This is it. I don't see anything else moving. It's near the center, which is good. We'll stop the blinking, and we'll overlay the known objects here, because that orbital elements are in Astrometrica. It shows me here's where it thinks it is, and here is, I believe, the actual position. And we can blink these back and forth, and you can see that the box is a little off from where it's predicted. That's pretty normal for these newly discovered objects. It's not too far off. So the little box is a good help. It definitely helps confirm this object. So we'll take our measurements, Let me zoom in a little here so you can see what I'm dealing with. It's not a sharp dot. I was looking down pretty low in the sky. This is about -11 declination. You can see at the bottom here. So it's down fairly low in my sky, which contributes to the blurring. So we'll see what we get here. Click on that. The centroid, well, it doesn't look great, but that's probably as good as it's going to get. So I'm not going to mess with that. Do a search. Here are all the possible objects that are close by. We see that this one is off by 0.2 of an arc minute in RA and 1/10 in declination. This is the observed minus the calculated here. Magnitude 19.2, so it's certainly not too faint for me on my system, but a little bit of haze was around last night, and I was looking down pretty low in the sky. So we'll accept that as one position. We'll go to the next, do the same here. Look at the centroid, it's not great either. We'll see what we get. Same differences here, that's a good sign. Click OK and accept. Okay, so now if we come up here to View UMPC Report file, we have these two measurements. These are what we want to add to the previous measurements from other observatories and compare our observations with those. So to do that, I go to the Minor Planet Center's website, and in this case, since this is a NEO confirmation object, I go to that page and I do a search for, let's see, P10AFQA. Okay, here's that object. We see there are now 26 observations today. There were less considerably last night. So I'll select that object, get ephemeris, and before we got the orbits from here, but now we want to go to the observations. These are the existing observations that have been made. Here are all these observations. Here are the ones I made last night. So I'm going to copy all those with a Control A and then a Control C to copy them. I'm going to open up a plain text file in Notepad and a Control V to paste them. Now what I want to do, I want to take my measurements from last night that I've already submitted out of here, because we're going to go through the process of adding the ones that I just did. So just pretend that this is what we downloaded. Your observations are not in here. And we'll say this is a text file. What I do is copy that file, save as, and I give it the name, the object, and then I stick OBS for observation at the end. Okay, so now what we want to do is add our observations here at the end of this file. So we come back to Astrometrica and we'll copy those and paste them here at the end. Make sure everything lines up correctly. You may need to insert or delete a space, but you want all these to line up. If you're just getting started, you're not going to have an observatory code here. I'll talk about that in a minute. You'll have to essentially create, what I find is easiest is to create a fake one and then add it to the list of observatories that Find Orb is going to use. But for now, we'll go with this, and I'll talk about that in just a minute. So here are our two observations that we just made. We've tagged them on at the end here. It doesn't matter if they're out of time sequence, and we'll resave that. Okay. Now, we go to this Find Orb program, which is a great free program, and we'll open up that text file. I happen to have it in my downloads folder somewhere up here. Should be near the top. All these things I've downloaded. Okay, here it is. Open that up. Find Orb is looking at those positions and trying to calculate a preliminary orbit from those. So here we go. We look through the list. Here are my observations, these two from W25. You can see it's put them in correct time sequence. It's moved them from the end to their correct place and time. And over here in these two columns are what are called the residuals, the observed minus the calculated. And here's an indication of how good the overall positions are with a mean residual of 0.21 arc seconds. So if you look at mine, this first one here, it's not great. It's greater than the mean. Same with this second one, greater than the mean. They're both less than 1 arc second, which is really what we're shooting for. So these are what I would consider useful observations. Hopefully the Minor Planet Center feels the same. They will probably use these in their final orbit calculation when they publish that. So that's good to see. Now, I think that's it for this part of the demo. It's pretty simple. You just copy and paste your observations here into this plain text file and load it into the Find Orb program. There's a lot of stuff that this program does, but for simply checking your measurements before you submit them, which sometimes I do, especially for faint objects. When I was getting started, I was checking all of them, so there's certainly nothing wrong with that. Once I got a little more confident, I would just submit the orbit or submit the positions. But for the faint stuff, I typically, especially the new objects, I typically always run it through Find Orb and compare them with the other positions. Now, if this object was not one of those new objects on the NEO confirmation page, but it already had a preliminary designation, or if it had a number designation, you wanted to get the known positions for those and compare your positions with those, then you need to do it a little differently. If you go back to the Minor Planet website, go here and down to the Orbits and Observations database. This is where you can type in the number designation or the preliminary designation, such as, let's see, 2017 BM 123. And it is case sensitive, and the spaces are needed in here. Asteroid that I did earlier measurements on. Click on Show, and here it shows a bunch of stuff about the orbit based on the positions that were submitted. Here are all the observations that were made for this. It was discovered by a Pan-STARRS telescope in Haleakala back here in January 31st. Somewhere down here are here's some of my measurements. So what you want to do is download all this stuff, and to do that, what I do is right-click on this, save link as, and then give it a name. It comes with a default name. You can see I've already downloaded this, so it's adding this parentheses 1 at the end. Typically it would just give you the name. So it's already naming the text file for you. If you want, you can stick OBS in here to note that they're observations, and save that text file. So now here's this text file. Unfortunately, Notepad does a poor job with the word wrap, but this is the same format as this text file. It really just doesn't have the word wrap done here at the end. However, you can now add your measurements. I would suggest probably opening this up in another editor. Probably WordPad is going to show you the format better. It's going to show it to you in this format where you can easily add your measurements at the end. But the process is basically the same, where you copy and paste the measurements that you get here out of Astrometrics and paste them here at the end and run through Find Orb to check your measurements. So basically it's the same process as the first one I described, except that the source for the observations is in a different location here on the Minor Planet website. First ones we got from the NEO confirmation page by picking the object, get ephemeris in the observations, and here's the 4 observations that you would use. The other one came from the orbits and observations database page. So that's how you can use the program Find Orb to check your measurements before you submit them. I think it's certainly a good idea to do that when you're getting started. Now, I mentioned something about an observatory code. Find Orb needs to know where you're located on the Earth because it does corrections for parallax. It basically, I believe, corrects your topocentric positions that you submit into geocentric positions, and then uses those geocentric positions to do these orbital calculations. So you need to tell Find Orb where you are. And if you don't have an observatory code, then here is what I suggest doing. There's a good help file on the Find Orb website. If you go to projectpluto.com, go to Find Orb. Down here is what to do if you don't have an observatory code. And it explains how you can tell Find Orb program several different methods of how to deal with getting Find Orb to know your latitude and longitude where you made the observation. So I suggest you read this. If you're just getting started, you won't have an observatory code yet. So hopefully that explains a little bit more about how to use Find Orb to check your observations before submitting them. And I thank you again very much for watching these videos.